to Demolition Overview Part 2 by the National Demolition Association. I am Larry Joswiak, Director of the Office of Construction Safety Training at OTI, and your moderator for today's session. Today's session will last approximately 90 minutes. There are two topics for today's session: safety protocols in demolition robotics and safety protocols in demolition fall protection. It is my privilege to introduce today's speakers: Tim Barker, Program Manager for AECOM, and Don Collier, Principal and Director of Field Operations for Milburn Demolition. I will now hand it over to Tim.
Great. Thank you, Larry. I appreciate that introduction. I'm going to be speaking today on the safety protocols in demolition robotics. This presentation was developed in partnership with the National Association of Demolition Contractors, or the National Demolition Association. And I am your instructor today, Tim Barker, with my partner, Don Collier, who is a subject matter expert on demolition with robotics. Our objectives today will include the introduction of the NDA, standards and references. We'll talk about the history of robotics and demolition, typical configuration and attachments used in the robotics, as well as what their purposes are, and the various scopes that utilize robotics in demolition. We'll have a couple safety topics that we'll talk about towards the end, in addition to the safety moment, about a caught between incident, actually two of them, and then we'll close with what to do to prevent those incidents. The National Demolition Association represents nearly 500 firms and about 400,000 employees across the demolition industry. Our mission is to provide members with the tools necessary to be leaders in environmental stewardship, safety, education, professional competency, and government advocacy. Our vision is to be recognized worldwide as a source for all things demolition while serving our industry. The latest safety resources that we develop at the NDA provide on-the-job safety training to their employees, as well as classroom setting. They include the Safety Handbook, Robotics Pre-Engineering Survey, the NDA app with 70 different safety talks and job hazardous analysis available to you. There's also guidance documents on high-reach excavators, ANSI standards, and my favorite, the Foundations of Demolition Management. This is a four-part, four-module course, 40-hour course, focuses on demolition estimating, demolition project management, demolition cost tracking, and demolition risk management. This 40-hour certificate course is currently being developed into the first ever demolition certification. As program manager for AECOM, D4 Services, I have over 30 years of experience, 20 years as a demolition contractor, working for one of the top 2-3 firms in the industry. In the last 10, 12 years for AECOM as the program director for decommissioning, which also encompasses plant deactivation, decontamination, demolition, thus our acronym D4. I'm also the Demolition Center of Excellence at AECOM's Technical Practice Group leader. Don Collier is Principal and Director of Field Operations for Milburn Demolition and Dismantling. He has over 25 years of experience in the demolition industry. Don's experience has seen him in the role of foreman, superintendent, now as principal, and today as my subject matter expert and co-trainer in this presentation. For more information on the National Demolition Association, you can go to our website. It's provided here, demolitionassociation.com, or call us at 202-367-1152 to learn more. I'm going to start this presentation with the safety moment. One in particular that I thought about that could have been prevented had we utilized a safety or robotic demolition tool on a project. It was a parking structure that had been built around on 4 sides. It was actually an office building above it, and it was used for storage underneath it. So it was truly a project that was surrounded on all sides. We performed the work with many hazards every direction that we went. And in performing the selective dismantlement, demolishing of these elevated concrete floors, we were using a concrete floor saw, 60-inch diameter diamond blade, to cut portions of this pan deck floor out so that we could lift it and lower it. Had we utilized the robotic demolition tools that we'll be talking about today, we could have prevented the incident that I'm about ready to share with you. And so the saw cutter was working on the edge. It was a cold night. Unfortunately, the water was starting to freeze, and water has to be used when you're using a diamond blade saw. He was by the edge, and while we were cutting out a portion of this parking structure so that we could lower it to the ground below with the crane, the load grabbed the blade. It binded the blade in between two pieces of concrete, and it literally flipped the saw over and off the edge of the parking structure. And when I say a floor saw, this floor saw was as large as a Volkswagen. Fortunately, the person that was pushing the floor saw or standing behind it wasn't holding onto it or didn't catch his clothes or his safety harness. And so he was safe. But again, as you'll learn in this presentation today, that accident could have been prevented by using a demolition robotic tool. There are many OSHA standards that pertain to robotic safety, and I'm not going to go over all of them here, but just touch off on a few. The second one, subpart C 1926.21, that's safety training, something that we need to provide for all our employees as contractors, engineers, and for OSHA to understand the hazards in the demolition workplace. Others include tools, electrical, fall protection, and then ultimately subpart T, which is demolition. So the history of robotics and demolition goes all the way back to the first unit that was built by Brock. They're out of Sweden. It's 1976. They soon started to mass produce them in 81, and currently in 2020, there's over 3 to 5 manufacturers of demolition robotics. And I'm sure there's probably thousands, if not hundreds of thousands, being currently utilized today. Is that correct, Don?
Correct. And there's tens of thousands that are in use just around the United States and tens of thousands around the rest of the globe.
Excellent. Thank you. So powered units have to be powered. Most often this is electric power via hard connection to the existing service. And then that electric power is then connected to a generator and or diesel engine to the actual robotic unit. Is there anything else to add to that, Don?
The diesel powered unit just became fruition recently in the past, I think, 5 to 7 years. It's a great attribute. But one of the unique things about the robots is that they are mainly powered by electric and can be used in smaller confined spaces where ventilation can be an issue.
Great, thank you. The typical robotic configuration is seen here in this figure, where you have a power cable, main body, track assembly outriggers, 3-piece boom, and attachments. And you can see here from this figure that the robotic tool can reach above its head, above its working platform, adjacent to, and just below. Is there any other configurations or ranges can be achieved with this unit?
Nope, you've got it covered.
Great, thank you. So typical robot attachments include the hydraulic hammer, as seen in the picture above, and the bucket below, grappler and concrete crushers, metal shears, mining, tunneling tools, and many more. With these various attachments, the robot and operator can cut through steel, concrete, asphalt, grind through material, dig holes, and various other things can be achieved with it that cannot be achieved with workers on maybe a jackhammer or using a sawzall. Purpose of robotics and demolition is oftentimes reducing the fall protection concerns of operators by allowing them to perform work from a safe distance while tied off if necessary. So I'm going to talk about this a little bit. Don, you can correct me where I go astray. But the earlier models, there was a cord that went to the operator as they were able to stand away from the Brock or the unit. And if it fell over an edge or into a hole, it would disconnect. But you had corrected me that now there's a Bluetooth connection between the actual control unit and robotic demolition tool. Is that correct?
Yeah, that is correct. All of the newer units within the past 8 years or so, I'd say, are all via Bluetooth. So they do not need a hardline connection to the operator itself. They can be run around 1,000 feet away, but the challenge is always having the operator be able to visually see his work and still operate the machine remotely.
Yeah, I'm glad you brought up the 1,000 foot away. I know that our company was somewhat involved in the Fukushima incident, and they utilized a number of Brocks that went down into lower areas of the plant that was highly contaminated with radioactive material. Were able to perform various functions at remote locations, keeping the workers or the operators safely away from high radiation source. The other purpose of using robotics and demolition is you can reduce air quality concerns. that are created when you're operating diesel equipment inside structures. I guess, Don, this is because you can hardwire this to an electrical source. Is that correct?
Correct. You hardline electric to a building, a generator, any different power source that you have on site.
As I see here in this picture, this appears to be a smaller unit. So they come in various sizes. I assume small enough to get through a 30-inch door and then large enough to really perform some heavier work, maybe in an industrial plant or a large commercial building. Is that correct?
That is correct, yes. Anywhere from 1,000-pound machines up to 15,000 plus.
Excellent. And I've also, and I'm sure others in the demolition industry, have taken excavators and removed attachments and held them either with a crane or another type of tool and used the actual excavator as kind of a robotic tool. In my situation, I hooked up a servo motor to the control handle so that we could just utilize the excavator as a hose to power the hydraulics while we use the attachment some 100 feet away. So I'm sure there's many different configurations and applications for the use of robotics and demolition. Is that correct, Don?
That is correct. I'll touch on a couple a little bit later on.
Excellent. Other purposes of robotics and demolition is reducing the environmental concerns by allowing operators to stay in controlled areas while operating the equipment. I provided an example earlier on a rheologically contaminated project, but others could be maybe a dust, silica dust. Maybe there's a lead-based paint concern as you're demolishing painted surfaces. What other environmental concerns, Don, could there be working in close proximity of a structure being demolished?
The main reason for robotic units is the elimination of health hazard with fumes. That is the primary goal of this machine used in the demolition industry. The diesel units are great, but the electric motor and electric powered units create the safest working environment in basements, in other, I don't want to call confined space, but tighter space areas for lack of ventilation.
Whereas the diesel and other units create carbon monoxide, and you're able to mitigate that risk by using this electric powered unit. Great, thank you. The other benefit of robotics and demolition is reducing back and other injuries that commonly occur when demolition work is performed with hand tools. I know this very well, starting early in the industry, working my way through college. You quickly discovered you don't want a job operating a jackhammer. And this tool prevents those back-breaking jobs and the injuries that result from them. Is there anything else to add to that, Don?
No.
Great, thank you. Other purposes of robotics and demolition include reducing the noise and vibration with the use of concrete crushers and shears in areas where traditionally heavy equipment does not work. And it reduces the weight of the equipment for situations where the floor loading is a concern. This clearly has been a concern of mine in the past where I've put heavy equipment on elevated floors or the contractors we were managing did. And as you can see here, there's some post shores underneath this unit. Just a few, whereas if you had an excavator or something larger up there, you probably couldn't even see through the floor beneath the equipment in order to maintain a safe work platform. Other purposes of using robotics and demolition is it increases the production of the removal as compared to hand tools. Again, it's not hard to see here in this picture how long it would take a number of workers to safely pick up that large piece of concrete onto some type of dolly or device and move it off the floor, whereas the robotic tool can pull the concrete away from the edges, it can crush it, it can break it, and with a shear attachment can cut through steel, allowing you to work your way literally through a building from the top down. Is that correct, Don?
That is absolutely correct. I'll touch on a few more later on, different uses for the machine.
Typical demolition scope performed with robots include concrete breaking, crushing, slab removal, as we saw in the last photo, metal shearing, wall demolition, ceiling demolition, chimney stack demolition, masonry demolition, pipe, mechanical equipment removal, and loading of demolition materials. I just have to note, I've seen some pictures. I haven't done it myself where demo contractors have elevated robot, Brock, or other type of unit, some 100, 200, 300 feet, 100 meters in the air. And then they utilize that tool from the operator safely at grade below to demolish chimneys and stacks. I'm sure there's other things that you're going to tell us, Don, that you can use it for that's maybe not as traditional.
Yes. Here's a few other options On the right side here, you obviously have one of our Brock robots. And what that attachment is on there is a vacuum attachment that's operated by air, just battery air. There's only a 4-foot high ceiling in this area. It's on top of a large high-rise building. So the robot is capable of working in this confined space without the exhaust fumes, and manpower is not needed to lift these large, heavy pieces of concrete out. The robot does it, puts it onto a cart. The one on the left is obviously the hydraulic breaker. This is creating a floor opening, taking the place of, quite a few people with jackhammers.
Don, that's fascinating. So the unit to the right has a vacuum attachment that provides enough suction for the operator to pick up a large piece of concrete that has been previously saw cut. Is that correct?
That is correct. Yeah, there's different size adds for that vacuum, but upwards of 1,000-pound pieces of concrete that small machine can pick up.
Excellent.
What you're seeing here in this video is a robotic machine with a hydraulic breaker. This is in a high-rise building of a large metropolitan area. Machine is brought up via freight elevator to this work area, and it's breaking out a floor opening. There's catch deck scaffolding underneath that's controlling the material from falling below. But this is once again, bringing air hammers up to large metropolitan building. This is eliminating back injuries. This is eliminating hand injuries. So as you can see in the video that you just witnessed, this small robotic machine takes care of just about the work of 10 humans. So it's very much a no-brainer on how this machine can outperform a human, as well as keeping all of our employees safe in doing so.
Great. With that, we're going to talk about a few hazards caught in or between when utilizing robots. The first one, the hazard alert warning, was issued by the Washington State Department of Labor and Industries. It's a fatality assessment control evaluation, 2019. And the second was robot with metal shear attachment. With that, I'll hand it over to Don to walk us through these two hazards.
The first event description, an operator was working for a specialty trade contractor using a machine fitted with a shear attachment to demolish an HVAC system. The operator wore a waist-mounted remote controller connected to the machine by wire, which, as I explained earlier, there is Bluetooth versions out now. As the operator repositioned the machine, he had to move the power cable, which is at the rear of the machine, so everybody's aware of that. Before lowering the outriggers, he attempted to move the cable. He bumped the remote against the machine. The operator had not put the machine into emergency stop mode, so it moved and pinned him between the outrigger and a wall. The operator tried to free himself, but lost consciousness. According to Washington FACE, a coworker saw that he was pinned and slumped over the machine. The coworker then tried using the remote control, but the machine wouldn't move. Other workers cut the power to the machine and tried to move it out of the way with a skid steer. After multiple attempts, they were able to rescue him. The operator's chest was severely crushed, causing him to be out of work for several months. Operator had been with his employer 6 months and was reported to be an experienced operator of these machines. He usually worked with a partner, but was alone at the time of the incident.
Thank you for that, Don. Second, hazard alert number 2, caught in or between. I'm going to hand it back to Don to walk us through this. Thank you, Don.
Thanks, Tim. And this hazard alert number 2 is somewhat similar to alert number 1. An operator was using a machine with a breaker attachment to chip concrete as part of a generator installation project on the road. He was standing in a tight spot between the excavation wall and the machine. As he tried to apply more pressure on the tip of the breaker, the front outrigger raised off the ground. The machine was suddenly shifted forward and the outrigger came down, crushing his foot. He was able to use the remote control to raise the outrigger, but suffered broken bones and nerve damage. Washington FACE says. The employer conducted a job hazard analysis that identified the swing radius of the arm as a hazard, but did not recognize the potential of being crushed under an outrigger. The manufacturer's safety instructions warn never to stand where there is a risk of being crushed. The operator had worked in construction for 23 years, but had only operated the machine for 5 days. His training consisted of a hands-on demonstration and a brief review of the operator's manual.
Thank you, Don. We appreciate that. So prevention of caught in or between incidents. Well, operators should be properly trained on all robotic equipment prior to use. You notice in the introduction, I talked about the importance of training that OSHA requires. Now, granted, there may not be a specific training module or class provided for many of the things that we do in the demolition industry. Most of the manufacturers, whether of robotics or excavators or cranes, high-reach excavators, would never envision the ways that we use these equipment, these tools to bring down large structures. So it's up to us as employers, owners, engineers to provide the training to the workers. And as such, we at the National Demolition Association have developed a 40-hour certificate program, but even that is inadequate for what employers only can and should provide to their workers to keep them safe. Operators should also read all instruction manuals, manufacturer warnings prior to their use. I would add this should be part of the training also. I've often seen contractors, and I've been guilty of this myself, providing workers 3 inches of information and then giving them all of maybe 10, 15 minutes to review it, having them sign a cover page that says, I thoroughly understand and have read and will comply with all the information in these documents. Well, that just does not cut it. So I would tell you and challenge all employers, contractors, owners to provide adequate training, provide the time required to equip workers to safely and successfully execute their work. Here are some tools that we've used in the industry. I'm sure some that you're very familiar with. Job hazardous analysis should always be utilized for robotic demolition work. And this should be updated as tasks and positions change. In this example provided by the National Demolition Association, you can see where it provides that information, or at least the cells for you to populate to provide that information. To prevent these types of hazards, you should control the access zones. They should be established for each robot and the attachment. That means it's a controlled access zone. It should never be entered by anyone during the robot operations. Other safety items to prevent caught in between incidents is kill switch on the remote control. They should always be activated prior to entering the zones. Robots work should utilize spotters whenever feasible. That means you're working somewhere, you've got somebody else working alongside you, looking at those blind spots, those areas that you may not see as the operator. Unfortunately, you may back into a hole or walk into something you shouldn't because you're so focused on the work at hand.
Thanks, Tim. On top of what you were just speaking of with the kill switch, I wanted to let everybody know that there is a dual switch startup for these robots. No matter who the manufacturer is, you have to apply 2 different switches to start the electric motor of the machine. And there is an auto stop that both these machines from the factory are set at 3 seconds, meaning if you remove or do not operate the machine, it will automatically shut down after 3 seconds. Now, this is adjustable. So I can't comment on the 2 caught between incidents, but there is an adjustment that you can adjust that length in which the auto stop comes on. I highly recommend that it's to be left at manufacturer specifications, which should be right around 3 seconds. It'll automatically stop.
Excellent. Thank you, Don. We appreciate that. For more information, please visit thedemolitionassociation.com or call us at 202-367-1152 to learn more. Thank you very much.
Don, there were a few questions that came up for the safety protocols and demolition robotics topic. The first question I have is, are there industry resources besides the National Demolition Association for training on robotics?
Thank you, Larry. Yes, there are. The 2 main robotic manufacturers, Brock and Husqvarna, both provide on-site training with written certificates with the purchase of a new machine and or a rental unit and or at will. So they can be called at any time to do the training, which is approximately a full 8-hour day of training. They go over in this course the safety, the operations, and maintenance of that machine. They do also both provide a train-the-trainer course, which I would recommend. So this would be the easiest way to train your top operator and get him or her certified to be able to train any and all other operators that are in the company.
So Don, I got a follow-up question for you on that. What if you bought one of the other brands?
Both of these two manufacturers would train on the other brand as far as operations, but they will not train the safety aspect of a machine that they have not manufactured. So currently there's 2 top manufacturers that provide training. Now, as far as certificates go, there is currently no expiration date on these, but the manufacturers recommend 3 to 5 year refresher.
Okay, thank you, Don. The next question is, with the robotics, is the manufacturer's written approval needed for fabricated attachments that are installed on any robotics equipment?
Good question. Each manufacturer gives recommendations for the appropriate attachments based upon the task, the weight ratio, the hydraulic pressures, the flow, etc. And that's based upon their engineering to determine that that particular attachment is going to work properly with that particular robot. You do not need a written approval process for fabricated attachments, but it is extremely recommended to go with manufactured attachments that are designed for that particular robot from the manufacturer of that machine.
Thank you for that, Don. Our third question is, can you provide examples of when robotics would be used versus manual labor for demolition?
Absolutely. Primarily, the easiest way to think of it is leading edge work. This is the machine for it. So exterior walls, stairways, floor openings, basement slab removal, basement excavations inside of occupied buildings. I know Tim mentioned it earlier. Work in nuclear plants is huge for these robots because employees can't be in the radioactive environment, obviously. Another large thing is blast furnace cleanout. Controls downtime heavily of blast furnaces. They can do very fast shutdowns. And the employee doesn't need to be close. The robot can do the work to clean out the blast furnaces. That's just to name a few.
Thank you, Don. And our last question is, what are some challenges when using robotics equipment?
Good question, Larry. Getting the power source to an area can be challenging depending on the type of job site you're working on. If it's, like I've said a couple times, high-rise buildings and things like that, you're obviously having to get power from the building itself. So that can be a bit challenging sometimes. The largest thing that we touched on in some of these case studies is, keeping operators a safe distance from the machine, but still being able to perform the work safely by visually seeing their work. So that can be tricky because, yes, you can operate at 1,000 feet away, but you can't see what you're doing safely. So that's always a challenge to make sure that the employee is safe at a safe distance, but yet can still see the work. And then one last thing is educating clients on the capabilities of these machines. They're very small, so they do perform a tremendous amount of work compared to their size. So education is key, whether it's clients or employees, educating them on what the possibilities are for these machines.
Thank you, Don. This completes the questions for the safety protocols and demolition robotics.